So what is the technique used to calculate what is the value of R? Okay. So once it is identified, so this R, that is along with the data, that is k bits plus R, is added and it is forming the code word. Okay, it is of size n bits and this is sent through unreliable transmission. Okay, unreliable transmission means it may not ensure 100% what is sent, what is delivered. Okay, in between either there may be interference of the signal or there may be noise added to the signal. Okay, so due to that the data may get corrupted. Okay, so once it is received at the receiver side, okay, n bits, it is called once again code word. So now that code word is sent to the checker. Okay, so checker is having a particular logic where it is going to check the received data is having any error or not. Okay, how it will check? So the checker is going to check the received data is having error or not by using that extra bits. Okay, using extra bits it will check it. So in case, so this is actually diagram with respect to error correction. Okay, in case if it is error detection, so you will be having two possible outcome. Okay, in case if there is error, so you will be having here the output, it can be, the output can be discarded because it is having error. In case if the module support even correction, okay, after identifying the error, it is ready to correct the error. So then in that case, it will correct that error and the valid data is sent to the data world, I mean delivered to the receiver. Okay, so this is already, I told you people to go through this example. Okay, it is just a continuation of another, the 3-bit example, whatever I have given data word, similar to this. Okay. So next we'll move on to Hamming distance. I think this also I just started. What is Hamming distance? So in between, if you have any questions, you can ask me. Okay, don't keep quiet. So the main concept of error control is Hamming distance. So that is how to find the Hamming distance. Why this is called Hamming distance? So the name it is given just because that is the name of the scientist. Okay, Hamming is the R.W. Hamming. He is the scientist name. So the same name it is given here to check how many number of bits got corrupted. Okay. So Hamming distance between two words is the number of difference between corresponding bits. Okay. So how to calculate Hamming distance? So you take the first number, take the second number, okay, apply the XOR operation. Okay. And here how many number of ones you are going to get. So that indicates the Hamming distance. Okay, so this also I have already explained. So you take any other example here, you can take 0, 0, 0, 1, 1. And what is the Hamming distance here? You just apply here, you will be getting two ones. So that indicates the Hamming distance between, I will tell why Hamming distance. So the Hamming distance between these two words is 2. Okay, so similarly you can just take any number up and in the result you count how many number of ones are there. Okay, accordingly you can come to know what is the Hamming distance between two words. So here what are these two words? One is the data that is sent and this is received. So what is the difference between these two? What is the distance? So that is calculated using simple XOR operation. So here Hamming distance and error. So Hamming distance between the received word, okay, so whatever it is received at the receiver side and the sent code word is the number of bits that are corrupted during transmission. Okay, what is the difference you are going to get? So that tells how many number of bits got corrupted. Okay, so if you want to know using Hamming distance, so what is the number of errors got or how many bits got corrupted, so you have to use this simple method. Okay, just take both the numbers, apply XOR operation and count number of ones. So here whatever the count you are going to get, so that indicates number of bits in the error. Number of bits, sorry, error. Okay, so out of this complete data, so 3 bits got error. Okay, so here we are not going to identify the location or correction, just we are detecting the number of errors using Hamming distance. Okay, you can just use this method. I think everybody understood now how to calculate the Hamming distance. You may get 2 to 3 marks by giving a set of code words. Okay, find the what is the Hamming distance between these two. Okay, you can get a simple problems if you're able to calculate. Okay, so what is the minimum Hamming distance here? So your minimum Hamming distance indicates the is the smallest Hamming distance between two all possible pair of set of words. Okay, so it is just a collection. Okay, how you are going to calculate what is the minimum Hamming distance? So that can be calculated using all possible pair of sets of words. Okay, whatever the combination of code words you are going to get, based on that you can calculate. So that is represented with minimum Hamming distance is represented with d min. Okay, d min. So here what is d min indicates? So that is indicating the minimum Hamming distance. So now how to find the minimum Hamming distance here? Find the Hamming distance between all possible set of words and select the smallest one. Okay, you need to find the all possible words. Okay, all possible words. Among those, select the smallest one. Okay, so that the smallest one will do some problems on this. You need to calculate what is the distance between all possible pair of set of words. Okay, among these, which is having minimum distance. So that is called as Hamming distance. Okay, that you are going to get as a Hamming distance. Okay, so we'll try to do some problems how to calculate the minimum Hamming distance. Okay, so this is based on table. Uh, this is based on table 10.1. Okay, so let me just go to the textbook and show you the 10.1. That is just to save my time. Okay, so this is the table. For this, you are going to find out all possible combinations. Okay, so that is some of the combinations are taken here. So to find the distance, it is not with respect to data word. You need to consider the code word. Okay, so you need to take possible combination of all these code words. Okay, one is 00. You take combination of 00 with all possible 3. You will be getting 3 combinations. Okay, similarly take this as a code word and make pair of all remaining code words. So that is how you need to calculate all possible code words. Okay, so now how to calculate the minimum, or first we'll calculate the Hamming distance between all possible words. You can just check it. Okay, 00011, so it is 2, then 00101, it is 2, then it is 2. Okay, you can just keep checking. So how I got 2? How I got 2? It is just a XOR operation and counting number of ones in the result. Okay, so that gives the minimum distance, I mean Hamming distance. So now among these all possible set of distance, whatever you have calculated, which is minimum? According to this table, we are getting all the distance is equal to 2. Okay, in case if you get 1, so that becomes the minimum Hamming distance. So here according to this example, so the Hamming distance is 2. Okay, is it clear? So now you can just check it. This is with respect to another table where you have 5 bits. Okay, so this is another table. So here I have not taken all combination. Some set of combinations are considered here. Okay, so 0 is taken and it is made combination with all the data words. Okay, all the data words. So take this, make combination of this data word with all remaining code words, not data word, code word. Okay, So here we are finding the error in the code word, not in the data word. So this data word is converted into code word. Once it is received at the receiver side, now you are going to check is it any error in the code word or not. So for that, first you need to identify what is the distance between the two code words. So here what is the meaning of two code words? Consider this is sent and this is received. Okay, if that is the case, what is the Hamming distance? It is 3. Okay, here it is 3, here it is 4, here also it is 4, 3, 3. So here among these all possible combination of Hamming distance, which is minimum, so that is called as minimum Hamming distance. Is it clear? What is d min here? It is 3. In case if you have any one combination having 2, then once again d min becomes, it becomes 3, I mean 2. Okay, so to guarantee the detection up to S errors in all cases, minimum Hamming distance in a block, okay, minimum Hamming distance in a block code must be d min is equal to S plus 1. Okay, so this is very, very important. So this point is very, very important. So what exactly this statement tells? So to guarantee the detection of S errors, if you want to identify or if you want to identify S errors, okay, the minimum Hamming distance in a block code, okay, it must be d min is equal to S plus 1. Okay, there should be one extra word. In case if I tell d min is equal to 2, so 2 means it is nothing but S plus 1. So it can detect only one error. It can detect only one error. Okay, if I have d min is equal to 3, okay, it is nothing but 2 plus 1. 2 plus 1. That means I can find only 2 errors. It can detect only 2 errors. So you need to remember this formula. So that is called as minimum Hamming distance, and it guarantees yes number of errors can be detected. Okay. So now there is one diagram for this. Okay. So before going to the diagram, so let's take one example here. So that is for finding the minimum Hamming distance for the first code word. So table 1, you need to remember this table 1 and 2. Okay, this is table 2 where you have data word 4 bits. Okay, for that you are adding one extra bit to form the code word. Okay, so this is one table, and another table where you have data word 2 bits and code word 3 bits. Just remember those two tables. Okay, so in table 1, so minimum Hamming distance we calculated it is 2. Yes, no, in the previous slide I have shown for table 1 the Hamming distance what we have calculated is 2. Okay, and so here this code guarantees the detection of only a single error. I told if you are getting d min is equal to, so d min is equal to S plus 1. Okay, that is a formula. So it will ensure that it can detect up to S errors. It can detect up to S errors. So now according to table 1, so I got d min is equal to 2. So I'll just write that as 1 plus 1. Okay. So it can detect only one error if it is distance is 2. Okay. So for example, if the third code word 101 is sent, okay, one error occurs. The received code word does not match any valid code word. Did you got this from the table 1? See, that case study is very, very important. The first table, 3 bit. This is 5 bit. This one. Okay. So you just remember this. So we have calculated minimum Hamming distance. We got 2. Okay. So that indicates that it can detect only single error. Even we have observed in all the 3 cases. Did you observe? So if it is there is no error, so definitely it will match with the valid code word. In case if one bit got corrupted, okay, so this particular digit, okay, this particular value is not matching with any of the valid code word. So then you can come to know that there is one bit got corrupted. If it is corrupting more than one bit, it is not possible to detect. So this what I explained in the previous class. Okay, did you understood this? So using this, you can come to know that only one bit can be corrected, detected. If is only one bit is got corrupted, that can be detected. In case if it is more than one bit, that is two bit got corrupted, it is not possible. So sometimes the error may go undetected, okay, and invalid data is delivered to the receiver. So that is the third case what I explained. See, if you are not understanding any of the particular point, you just interrupt me. I will repeat. Okay. So this is with respect to table 1. So if two error occurs, however, the receiver code word may match, okay, match a valid code word and error or undetected. See, this chapter is very easy. Only thing is you need to understand. Understanding is very, very important. So next, the second block. Okay, that's what I told, the table, second table. So this table. So we have calculated what is the minimum Hamming distance we got for some of the combination. The minimum distance is 3, 4. Okay, out of these two, we came to know that it is 3. So in this case, so the code can detect up to 2 errors. Okay, so it can detect up to 2 errors. So just whatever the d when you are getting, make -1. So that will give the how many number of errors you can detect. Okay. So again we see that when any valid code word is sent, 2 errors create a code word which is not in the table of valid code word. Okay. So if it is 2 error, okay. In case if any 3 bits got corrupted in this according to this table, so once again, so error go undetected and invalid data is delivered to the receiver. Okay. So some combination of 3 errors change a valid code word to another valid code word. See here, if you are thinking, is it these methods are applied directly to the real time system? Okay, it may not work exactly. Okay, you may like it is not able to detect all the possible errors. These are all the basic one, the fundamental methods you're just learning. Okay, in real time, these methods are like advanced. They've added some more technique, and these methods are working in different manner. Okay, so because you people are beginner to this network, first you need to understand the small things. So like how in C language, how we learn if else statement. Okay, we'll just use based on particular condition to execute some message like that. So here we are going to discuss all these things. Okay, so when it comes to real time, whatever the methods they are using, those are all very different. Okay, so some of the methods of real time also I'm going to explain in today's class, but you need to learn. Okay, so some of them may be thinking like if it is lot of question may arise when you are learning these methods. Okay, so this is just a fundamental method. Okay, not the advanced method. Okay, so here I have already explained how to calculate minimum Hamming distance for error detection. Okay, so this is done, and here there is one small diagram that tells geometric approach how you can explain about the d mean. Okay, so you can just observe. So here you can assume that sent code word is x. Consider this is a code word is sent. Okay, it is just a simple explanation to understand about the code words. Okay, how to identify or how to detect the error. So here x indicates that is a sent code word. So that is there at the center of the circle with a radius s. So all received code words that are created by 0, okay, created by 0 to s errors or point inside the circle. Okay, so whatever the errors it is going to created during transmission, okay, all possible code words for that, it is represented within the circle. Okay, within the circle, and also there are some of the code word on the perimeter of the circle. So all these, the red dot, what you can see, so these are all called valid code words. Okay, so if you want to identify any error, okay, always the code word, it should not match with any of these things. Okay, it should go out of this circle. So in such cases, you can come to know that it is not a valid code word and there is an error in the received data. Okay, so even if it is corrupted, you just understand here, you can just see, pink dots or the circles. So that is indicating the corrupted code word with 0 to S errors. Okay, so how many errors you can detect? So always it should be, d min should be greater than S. Okay, so what is d min? So d min is equal to S plus 1. Okay, so d min should be greater than S. The minimum Hamming distance should be greater than S. The simple way, this is not like so important, just to understand like how the corrupted code words lies. Okay, it will be within the radius. In case if it is going out of the radius, so those set of code words are not able to detect the error. It may match with any one of the valid code word. Okay, and the error may undetectable. And also, so here whatever the dots that comes outside this circle, okay, so these are all valid code words. It will not be having any error. It will not be having any error. So here if I give d min is equal to 4, how many number of errors you can guarantee? Can somebody tell? So consider here, I am going to consider d min is equal to 4. Can somebody tell how many errors it can guarantee to identify?
3, ma'am.
Yes, you are right. Okay. So why? Because so d is equal to s plus 1. So if you want to know s, so it's going to be d minus 1, that is equal to 4 minus 1, and that is equal to 3. So you can guarantee 3 errors. Errors can be detected. Okay, or you can just remember it is less than minus whatever the value you have d min, so minus 1 if you do, so many number of errors you can detect. So here S indicates errors. Okay, so now with respect to correction, okay, so correction here we are not going to discuss as of now, so but still you can remember this point. So to guarantee correction up to t errors, okay, so you see I told we cannot correct all the errors, so there are, depending on the method, we have a limitation. Either it may detect only 1 bit error, okay, or it may detect only 2 bit error, like that. Okay, for that reason, to guarantee correction of t errors out of s error, so t errors in all case, in that case what should be the minimum Hamming distance? Okay, in a block code must be d min is equal to, okay, remember this formula, d min is equal to 2t plus 1. Okay, t indicates number of errors can be corrected. Okay, so we'll see later like how we can make use of this for data correction. Just remember this formula. Okay, I think you can now, just using d min, I think everybody are able to tell how many errors can be detected. Yes, no? So here this, I'll just go through one sample of example. So consider code scheme has Hamming distance d min is equal to 4. What is the error detection and correction capability of this scheme? So this code guarantees the detection of 3 errors. I think everybody and like agree for this, but it can correct only 1 error. Okay, so we have some limitation. Number of error can be corrected. It depends completely on the method. Okay, so according to this Hamming distance, so it can correct only 1 error. Okay, if it is anything more than 1 error, it is not possible. Okay, if this code is used for error correction, part of its capabilities, wasted error correction codes needs to have odd minimum distance. Okay, so here even this Hamming distance, it is not going to correct like even number of errors. Okay, it is not going to support for even number of errors. So Hamming distance can guarantee with respect to correction of errors only the odd numbers. Okay, like example, if the distance is having 3, 5, 7 like that. So here more importance is given to the detection rather than the correction. So the correction is only for one bit. So now in additional to that, we have one more concept in the same block code, the Hamming distance. So that is called linear block code. Okay, so almost all block codes used today belongs to subset of linear block code. So a linear block code is a code in which the exclusive or you can go for modulo 2 of two valid code words to create another valid code word. I think we have done this already in the previous case. Yes, no? So to find the valid code word, you can just add two valid code word. Okay, it will generate another valid code word. So here for that you can go with the modulo 2 or you can just simply apply exclusive OR operation. Are you getting the statement what is linear block code? So if you are taking two code words, okay, add these two, I mean using exclusive or mod 2 operation. So you are going to get one more code word that is a valid code word. So that concept it is called as linear block code. So how it works linear block code, let's go. So minimum distance for linear block code, we'll just discuss what should be the minimum and some other linear block codes. Okay, so we'll just take example of the same table. Okay, the first table 10.1. You can just write it somewhere this. Okay, it's not a difficult thing. Okay. So here let's go to understand what is linear block code. What is linear block code I told? So if you add two code words, you are going to get the third code. If this is the case, how you are going to calculate what is the minimum distance in linear block code? Okay, so you can just go through these cases. So the scheme in table 10.1 is a linear block code because the result of XORing any code word with any other code word is a valid code word. For example, XORing of the second and third code word creates the fourth one. So let's see. They have given just a statement. So you just take any two valid code word. You can just tell me any two valid code words. We'll just let me take 00 and 001. So 00, 00, is it 001 or okay 011. So you just add these two. Okay, just apply XOR operation. You're going to get 110. So you just check the table. Do you have 011 in? Obviously, it is a second code word itself. Okay, so that is a valid code word. Let me take instead of 00. So let me take the second code word 011 and the third one is 101. Okay, add these two. I mean apply XOR operation. You're going to get 0, 1, 1. 110 should be once again, it should be there in the table. That concept we call it as linear block code. Can you agree? We have this. You take any combination. Okay, if you want to take 110 and 101, we'll try that out. 110. I'm just taking the last code word and also 101. 110. Okay, so this is a second valid code word. See, when you add any two valid code word, it is going to generate the another valid code word. Okay, that's what the linear block code tells. Even you can just try with the table 2. Now whatever I have shown, this is for table 1. Okay. So for the first table, okay, the number of ones in non-zero code word are 2. Okay. So you non-zero means you should not consider the first one. Okay. So you just leave this. You just take all the combinations. So what is the distance you identify? Okay. So in all the other cases, the distance is 2. Okay. In our second code, the number of ones in the non-zero code word or 3, that is second table. I think we have already done in the previous slide. Okay. What is the d mean for table 1? It is 2, and d mean for second table is 3. So now there is no much concept regarding like a linear code. They have just given information like when you add two code words. Okay, so here we have four code words. Now you just add any combination, you will get the third code word that is belongs to this valid code word. Okay, so now considering that concept, so they have introduced one more method called parity check code. Okay, so this is very important. It can be asked. Okay, so what is this parity check code in the block code itself? So this is another sub concept. Simple parity check code is used is a single bit error detecting. So using this parity check code, I don't know if you have learned anywhere in other subject what is the meaning of parity. So normally you will be learning even when you are storing the data in the disk, it is going to use this method to check is it any data is corrupted or not. I think in operating system you will be learning. Okay, so a simple parity check code is a single bit error. So parity check code, it can identify only single bit error. Okay, it can identify only single bit error. So detecting code in which n is equal to k plus 1 with d min is equal to 2. So when I tell d min is equal to 2, so you should be knowing s is equal to 1. Okay. So even parity ensures that code word has even number of ones. Okay. So even parity and odd parity. So how to add this? See, this parity mechanism is introduced to find what is the extra bit we are going to add to the data. Okay. So there are some textbook they are referring even parity, and some other textbook they are referring odd parity. So as of now, we'll just move on to even parity. Okay. So in the same manner it works for the odd parity, but it is going to give preference for odd number of ones. Okay, so here we are dealing with the even parity. So now how to check the parity? How you are going to? So this is very important. Listen carefully. So how I am adding the extra bit code to form the code word. So here this is according to even parity. That means whenever the result or the data word is having number of ones is odd, you are going to add one. If number of ones are even, you will be adding a 0. So let's look into that. Understood, no? So number of ones is, if it is odd, you are going to make even by adding 1 at the end of the data. Okay. In case the second case, so in case number of ones are even, okay, it is already even. So you are going to just add 0 at the end of the data, and you are going to form the code word. So let's look into that for some of the examples. So here this is my data word. So here we have, there is no ones only, so that is considered is even, and just add 0 at the end. Okay, this is completely data, and this is extra bit called R. Okay, so now here how many number of ones we have? Only one. So 1 means it is odd. I need to make this number of ones to even by adding 1 at the end as a extra bit. Similarly, here number of ones is 1. So make it even by adding 1 at the end of this data word. And here it is even, so add 0. Okay, so this is called as parity check. So here we are using even parity. Here also it is odd, just add at the end bit 1, and here it is even, just add 0, here it is even 0. Okay, this is odd, add 1. So this is how you are going to prepare the parity code table. Okay, so how it is going to be useful to for error detection. Okay, so whatever the data to be sent, see, you just be interacting or ask some question, otherwise I will not come to know that you are understanding or not. Okay, so whenever the sender want to send the data, okay, so this data what is considered. Okay, this is the data the sender want to send, 0 0. So let me not take 0 0, I'll go with 0 1 0 1. So now this data what is not sent as it has to be converted into code word. Okay, so code word means after adding the extra bit whatever it is generating. So that means 0 0 1, and your number of ones are odd, so just add bit 1 to make it even number of ones, and this forms the code word. Okay, and this is sent through the transmission media and it comes to the receiver. So now receiver should be knowing that, so this is a mechanism is used. Okay, so this is a mechanism is used. So what the user is going to do, so the user is going to take like he will be looking for 0 0 0 1, and here what is the last bit, extra bit is added, so it indicates that 1, that means there should be odd number of ones in the data. Okay, so if it is exactly odd number of ones, if it is there, then this is a valid data. Okay, and this will be delivered to the receiver. In case if any one bit is modified, okay, so you can just see this is a corrupted bit. Okay, now it is number of ones are even, but here the extra bit is 1. Okay, extra bit is 1, but it is not matching with the even parity. Okay, that means the receiver will come to know that there is a error in the received data. Okay, so as of now this parity mechanism is used for just checking there is a error in the received data or not. Okay, there is no correction. So correction means it is once again going to be like the complex part, because it has to identify among these bits which bit got corrupted. Okay, how many number of bits got corrupted, everything matters. So here even parity it is mainly used for error detection. Okay, is it clear? So error can be detected easily, but how many number of errors according to this table? Okay, according to table 1, so d min was equal to 2, so you can detect only single error. So according to this table, C5 comma 4, so what is C5 comma 4 indicates? Code word. Okay, so code word is, the length is 5. Okay, number of data bits are 4, that is the meaning of this C5 comma 4. Okay, it can detect only one error. Even parity check code. Okay, so now you can just observe, so how this parity check code is calculated. So this is a block diagram used. Sorry, people are understanding, no? Any queries as of now? Any queries?
No, ma'am.
Okay, thank you.
No, ma'am.
Okay, if any queries you can just ask me immediately, I will repeat it. So this is a block diagram or the logic used for parity check code. Whatever I explained now, the same thing it is implemented using the circuit. Okay, and also you can have some program here to calculate the parity bit. So this is at the sender side. Okay, so there is nothing complex. The only thing is you need to remember how many data words, 4 bits, the A0 to A3. You need to start from leftmost bit. Okay, so A0, A1, A2, A3. Okay, 4 bits. So now these 4 bits are sent to a generator. You already know what is the function of generator. It is going to calculate what are the extra bits to be added. Okay, what are the extra bits should be added, that is value of R. Okay, so it uses the logic of parity check code and it will count number of ones. Accordingly, it will identify is it 0 to be added here or 1 to be added. Okay, so that is just represented as or not. Okay, or not should be calculated using generator. So now that R0 after calculation, it is taken here, okay, along with the data A0 to A3 plus this R0, okay. So completely this forms the code word. So before transmission of data, so it has to generate the code word. With the help of generator, identify what is the parity should be added. So is it parity 1 or 0? So you should know when to add 1 or when to add 0. So 1 should be added in case if number of ones here, if it is odd, to make it even parity, you will be adding 1. In case if it is already number of ones in the data word is equal to even, okay, then you will be adding 0 as or not, okay. So then send the data through unreliable transmission, okay. So whatever the transmission media currently we are using, it is unreliable, you cannot ensure 100% accuracy. So this is the code word received, okay. So just to differentiate the, so the terms used here different, that's all. So instead of or not here at the receiver side represented as q naught, then A3 to A naught to A3, it is represented as B naught to B3. Okay, just to indicate this is the code word at the receiver side. So now the duty of the receiver starts. So extract all these code word bits and send to the checker. Okay, so now checker is going to calculate. Okay, calculate. What is the calculation it is going to do? So that is called as syndrome. Okay, if syndrome, if it is equal to 0, indicates no error. Okay, if it is getting equal to 1, so that indicates that there is an error. Okay, so that is calculate. I told how to calculate the received data is having the error or not. Okay, where it will calculate the from the data word number of ones and check with the parity bit. Okay, if it is matching, so that is a valid code word. If it is not matching, so it will come to know that it is not a valid data word. Okay, and that is sent to design logic. So in design logic, so S naught here, what is S naught? How we are going to calculate S naught? So S naught you are going to calculate, just it is mod operation. Let me just write it here. S naught is equal to B3 plus B2 plus B1 plus B0 plus Q naught. Okay, so add all these, okay, add all these and do mod 2, do mod 2, modulo 2 operation. In case, okay, in case if you are getting S naught is equal to 0 after mod operation, see mod 2 is very very important. So if you are getting S naught is equal to 0, that means no error. So other than any value for S naught, okay, it will be possibly, you will be, when you are doing mod 2, the value will be either 0 or 1. If you are getting 1, okay, if you are getting 1, so it indicates that there is an error in the received data. Okay, so whenever if there is an error in the received data, if S naught is equal to 0, so it will be delivering or extracting the data word B naught to B3 and it will be delivered to the receiver. In case if S naught is equal to 1, okay, it will discard the complete data. It will discard the complete data. Just have a look into this diagram. If you have any queries, you can ask me. Diagram is very very important. It is similar to the previous one. Only thing is here I am very specific with respect to the bits. Okay, and also what is the operation used at the checker. See, the term generator at the encoder and checker is used at the receiver. Okay. Any queries? Okay. So if you don't have any queries, let me go to the example. Okay. So now consider no errors if the received code word is okay. So here I have S naught is equal to, okay, so here in the example they have given. So let us look at some transmission scenario. Assume the sender sends data, okay, 1011. 1011. The code word is created from this is What is the code word? You can calculate. Okay, number of ones in this code data is 1011. Okay, so this is the data word you should write. When you are writing about this, you should have a clarity about the data word and code word. So now I want to make code word. By calculating number of ones is odd here. So now I need to add 1 at the end to make it even parity. Okay, so this is the code word is generated. So now we'll have three cases here. No error occur. The received code word is, if it is received as it is, okay, without change, if it is received as it is, it will check the data word 1 2 3. So there are 3 ones and the parity is 1. So that means the answer is correct. Okay, it will extract the data word. Once again, if you go for thinking complex, there are a lot of things. Okay, even it is having some limitation. Okay, I'm just talking about this single parity, that means a single error detection using this method. Okay, not more than that. If it is more than one error, once again it may match with some valid code word, and the invalid data is delivered to the user. That thing also happens. So now one single bit error changes A0, A1. Okay, so among this, which is A1? So this is A1. No, this is A0 and this is A1. So it is changes. A1 means, consider, so this is changed to a 0 instead of 1. It is, when it is sent through the transmission media, it is changed to 1. Okay, and this is parity bit. Is it clear? So now consider this is a data received at the receiver side. So now receiver is going to calculate what is the syndrome for this. Okay, so 1 2 3. Okay, 3 mod 2, 3 mod 2, you are going to get 1. That means syndrome or S0, you are going to get it is 1. That means there is a error in the received data. Okay, are you getting? Okay, so what I am telling is the data that is 1 0 1 1. Okay, this is the data word, and to make it even parity, we have just added 1, and this form the code word. So now what I am telling, so consider this A1, this is A0 and this is R0. Okay, and this is A1, sorry, A1, and this is A2 and this is A3 according to the diagram. So now I am telling this bit is modified. So when it is modified, how it will be, that is 0 0 1 0 0 1 1. Okay, so this bit is modified. Now when it is received at the receiver side, it will calculate what is the syndrome value. Okay, what is the syndrome value? So it will just add all bits, that is 1 plus 1. Okay, that means you need to add, that is, this is at the receiver side going to be Q0, and this is B1 and this is B2, B3 and B4. Okay, so add all. Okay, so what is the answer you are going to get? 3. 3 mod 2. So the answer is 1. That means there is a error in the received data. There is a error in the received data. So this is one case. This is the second case. Okay. So we'll have one more. Consider if the parity bit itself, it is got corrupted. Okay. Anything, even if that is the case, so it is possible to identify. So actually this is the data. Consider now R0 is changed. 1 0 1 1. So when it is received at the receiver side, if this bit is changed. Okay. So now when once it is received at the receiver side, once again it will calculate a syndrome value. So it is going to get 3 mod 2. Okay, so still it is telling there is an error in the received data. Okay, this 1 indicates there is a error. It will discard the data whatever it is received. Okay, is it clear? Is it clear? See, understand, very easy topic, so you should not make it complicated yourself. If anybody like feeling difficult, you can just tell me, I'll explain. So now we'll just go with more than one error. Okay, so consider R0 changes and second error changes A3. Okay, so in that case, so this is R0 and this is A3. Actually it should be 1 1, it is changed to a 0. So now in this case the syndrome value is 0. Okay, so the data word 0 1 1 is created at the receiver. Note here the data word is wrongly created. Okay, so due to syndrome value, that means in case if you have more than one bit got corrupted, so you even parity, it is not going to check the error. Okay, you need to understand, even parity, it is not going to detect even number of errors. Okay, it can detect odd number of errors. You can just go through the fifth case where 3 bits got corrupted. Okay, A3, A2, A1, okay, are changed by errors. So if that is the case, the received code word is this. Okay, the syndrome is, when you calculate syndrome is equal to 1. Okay, so that indicates that there is an error in the received data. Okay, so this parity method, parity check method, detect one single error. Okay, and can also find any odd number of errors. This is very important with respect to parity check. So anybody is having any doubt, just take 1 minute time and just recall what I explained. So parity check can guarantee one single error detection, and also it can find any number of odd errors. If it is having even number of errors, okay, what is the meaning of even number of errors? Which bit, how many number of bits got corrupted, that indicates. Okay, if it is even number of bits got corrupted, so this parity check can identify the errors. If it is even, it is not possible. Okay, odd number of errors can be detected. If it is even, not possible. So the error go undetectable and invalid data is delivered to the receiver. Okay, is it simple? The concept is simple, you need to understand. So single parity check code can detect an odd number of errors. So this two-dimensional parity, it is not there for you. I'll just skip that part. Okay, so I want to do this. At least I need to complete this cyclic redundancy check. Okay, so this is very important and compulsory question, 8-mark question. Hardly it will take 2 minutes to solve this problem. Okay, if you understand. So here, in the previous method, what we have discussed is linear code blocks. Okay, but here you are going to learn cyclic code. So what is the meaning of cyclic code here? So cyclic code or special linear code with one extra property. Okay, so what is that extra properties? In a cyclic code, if your code word is cyclically shifted, okay, so if you shift whatever the data you are shifting here, and you need to add that back to the same number. Okay, so that is going to create the new code word. So that is the meaning why they have given name called cyclic code. So in the previous method, you used to remove the value after shifting and it forms the code word. But here you are rotating. Okay, whatever the data it is shifted, and that you are just adding back to the number, and that forms one more valid code word. You may be thinking why you are learning all these things. Okay, these are the fundamentals you should know to know the advanced or the complex method. So next I will be just taking till at least 11:30. Let me just finish at least CRC. Actually I planned for even internet checksum. At least we'll complete this part. Okay, so cyclic redundancy check and polynomials. In case if you feel at any point of time enough, you tell me, I'll just stop it. So why I'm taking this extra class is maybe next week I may not possible to take 1 or 2 class due to some training. That's why I've arranged this special class. Okay, so here we have CRC. What is CRC? CRC indicates cyclic redundancy check. Cyclic redundancy check, very important. Okay, So it's very, very important. Everybody should know what is the meaning of this. Okay, so I was explaining about uh, if you rotate numbers, you're going to get one more new valid code word. For that, so that example is not there here. I'm just going to this. Okay, okay. If you are just interchanging the numbers, okay, if you have instead of when you interchange or rotate the number, so you are going to get new number that is b naught, okay, b naught, b6, b5, b4, b3, b2, b1. Okay, that means b naught is just shifted back. So whenever if you do this process, it is going to create a valid code word. Okay, there is an example also. You can just go through that example. Okay, so this you can just observe this one. So this one is shifted left side and that is rotated back, added to the same number. Okay, and you got this number. So this is also a valid code word. So this technique of generating the valid code words, it is called as cyclic codes. And there is a method called CRC, that is cyclic redundancy check. Redundancy, what is the meaning of redundancy? Can somebody answer quickly? Don't
Adding
waste time.
extra bits
Yes,
for the existing code.
I didn't get you.
Add
Your voice is breaking. Okay, adding extra bits. Okay, adding extra bits, it is called as redundancy. And hardware implementation, I will be just keeping pending. So we'll just touch upon CRC and polynomial. Okay, so how to calculate CRC? So this is very, very important technique, and most of the technique in currently the in real time in networking, they are using this method, CRC method. I think wherever you go in higher semester, whichever the subject you learn with respect to network, so this is a common method they will use to tell how to detect the errors. Okay, so listen carefully, very simple method. So you can just observe. So here this is a data word of size 4. Okay, and code word is formed by adding extra 3 bits. Can you observe? So how these 3 bits are added? So that is the part of CRC. You are going to learn how to or how I added these 3 bits. What is the extra 3 bits I should be added to this data word? So that process is explained in CRC. Okay, that process is explained in CRC. Just a minute. So I don't want to waste time here. Let me just go to the method. So this is the block diagram for encoder. In the exam, most of the time they will ask for the problem, but sometimes they will ask you to write encode, explain CRC encoder and decoder. So whatever I explained for single parity, it is same, but here you are going to add extra 3 bits. That is important. That's all. The remaining thing all it is same. So now let's go to the method cyclic redundancy check. So you can just observe the encoder. What is happening at the encoder? So encoder, it is just making use of all 4 bits sent to the generator. Generator along with these 4 bits, it is adding 3 more bits because I want to send data of size 7 bit. Okay. So already data was it is having 4 bits plus 3. Okay, it is forming total 7 bits. But I don't know what is the 3 bits should be added. Okay, so for that initially the generator is going to take all 3 bits of zeros. Okay, these 4 data bits plus 0 is sent to the generator. I want you people just concentrate for this technique, very, very important. Okay, so all data words, 4 data bit words, and for the extra bits what you want to add, I don't know. Okay, so in the previous table there is already calculated and it is added here. So here I don't know for my data what is the extra bit should be added. So initially you need to consider 0, and this 0 3 0 should be sent to the generator. Okay, so generator it is having some logic here. It is going to perform division operation and it will calculate the remainder. Okay, so that reminder is added as an extra bit. Okay, so these 4 bit plus remainder whatever you are going to calculate 3 bits. it is forming the code word. Okay, so now the logic is lies here, generator. We are going to look into generator in detail. So just remember here, so it is going to do the division, whatever the data we got here. So that is your data will be like this. Even if I extend for 10 minutes, don't mind. Or if you felt enough, you just let me know. A3, A2, A1, okay, A0, and also these three zeros. Okay, so this complete data word is sent to the generator. So now generator, it will take this data word, okay, and it will do division. Okay, so that division is done using this number, and okay, the divisor is required, and this is considered as a dividend. Okay, and this dividend is divided with the divisor, you're going to get some reminder. Okay, so that reminder value is added to the code word, extra bits, and it forms the code word, and that is sent to the through the transmission media to the receiver. You can just observe what is happening at the receiver side. The reverse operation takes place. Okay, take all this as a dividend. Okay, sent to the checker. Once again, use the divisor. Okay, and you will be getting the reminder. So that is called as your syndrome. So depending on the value of this S0, S1, S2, okay, the remainder value, if it is equal to 0, there is no error. Same logic previous to the parity check. Only thing is number of bits are different here. So if syndrome is equal to 0, no error. Okay, accept it. Okay, and here this is here you are going to calculate the remainder. Okay, that is given to decision logic. Now decision logic, it is going to take decision based on the value of S. Okay, if it is 0, then accept, there is no error in the data. If it is other than 0, so it is going to discard it because it is having some error in the received data. Is it everybody understood this quickly? So that I'll explain one problem on this. Problem is very, very important. If any doubt, or do you want me to repeat the process? Do
Ma'am,
you?
can you repeat one again,
Oh,
ma'am?
yes, yes. So just listen carefully. Now, at least if you solve the problem, this diagram you can understand by yourself. So here what happens is, whatever the data word the sender want to send, for that it has to add the extra bits. Yes, no, redundant bits. Now what redundant bit should be added here? So that is decided by the generator. What the generator is going to do? It is going to form the code word. Okay, that is called as actually augmented code word, because I don't know the what are the extra bits should be added. So initially I am considering 0 0. Okay, so here my augmented data word will be A3, A2, A1, A0, and 3 extra bits 0 0 is added. This is called as augmented data word. It is sent to the generator. Now generator is going to consider this as a dividend, and that will be divided by the divisor. Okay, and you will be getting some reminder. So that reminder is considered as a extra bits and added to the data. You can just see the lines. Okay, added to the data of 4 bits and forms the code word, and that is sent to the receiver. At the receiver side also same process takes place. Okay, it is sent to the checker. Checker is going to calculate S0, S1, S2. Sent to the decision logic. Okay, so decision logic, it is going to check is S is equal to 0 or any other than 0. Okay, so that indicates there is error or no error. If it is 0, no error, accept the data. Okay, extract only the data part. Okay, so here don't worry about what is B3, B2, just for the convention to differentiate the data at the sender and receiver side, we have used these terms. Instead of R0, R1, R2, here I am just using Q0, Q1, Q2. Instead of A0 to A3, here it is just representing B0 to B3, that's all. If it is other than 0, it indicates that there is a error in the received data, discard it. So that is the logic. Understood now? And here the play role mainly by the divisor. Okay, so then who is going to give this divisor? Because we have data word, we know how to augment 3 zeros, all those procedures. So these are all standard divisors. Okay, You cannot take whatever you want, I mean whatever the sender want, they cannot consider. It should be a standard divisor. So I'll be talking about that divisor later, and this same divisor should be known by the sender and receiver. That's why this arrow mark you can see, when it is doing either at the generator or checker, it has to consider the same divisor. Okay, there will be an agreement or the protocol that will make exchange of this information between both sender and receiver party. Okay, whatever I explained, same thing here it is explained. So if you directly look into this, you may not understand. Let me just go to the notepad. Okay, I'll just go to the PDF. We'll try to solve the problem by ourselves. Okay, so here what is the data word I want to, what is the data I want to share? I'll just write it here. Just I will solve only one problem. Okay, if you understand this problem thoroughly, you can solve any number of bits, whatever the data they will give. Okay, this is a data word. So now I want to form the augmented data word. Why it is called as augmented data word? Because I don't know what are the extra bits, 3 bits should be added here. Okay, for that reason, so I'm just assuming these 3 bits as zeros. That is called as augmented data word. So follow the same step when you are solving the problem. 1 0 0, write the data word as it is, and for these 3 bits add 0. Okay, so now your data or dividend, so this is called as dividend at the sender side, it is ready. So let me just split 2 part here. Okay, so I'll just solving at the sender side now. So here what is the divisor we are going to use? Divisor, I will talk more about this divisor later. It is 1011. Okay, the same thing it is used at the receiver also. I told this is standard divisors you need to use. So now how to calculate or how to do the division? Okay, so take the divisor here, that is 1011, and here you write the augmented data word. What is augmented data word? 1001. This is the data, and augmented is 3 extra bits. Because I don't know what are extra bits, I am just adding 3 zeros to the data word, form the augmented word. Okay, so this is dividend. Okay, dividend. Then this is divisor. You can just note down all these things. Just till here, everybody write it in your notebook. Don't write everything, just this much. So this is the divisor and this is the dividend. Now you need to start the process. Okay, so now I'm just considering 4 bits, the first 4 bits of this dividend, 1001, for division purpose. So how to do the division, binary division here? So you need to check the leftmost bit. Okay, what is the leftmost bit here? If it is 1, okay, write the quotient 1, okay, and 1 into this divisor, you are going to get 1 0 1 1. I want everybody should ensure you are understanding. I think till here everybody understood, no? Understand carefully. I'm not going to solve more problems. If you understand one problem, you can do by yourself. So till here everybody written divisor, dividend. Now the division process starts. Okay, so how to do the division here? You just check the leftmost bit here, whatever the bit you consider first for division. In that you just consider the leftmost bit. Here I am going to consider 4 bit for division. Okay, because I have divisor 4 bits, I'll just consider first 4 bits for division purpose. In that leftmost bit is 1, so because of that I need to go for quotient 1 into this divisor. Okay, you will be getting the divisor as itself and write the divisor value here. Okay, so after that you can just add the XOR operation here. Okay, so 1 into 1 XOR with 1, that is 0, 1 0 it is 1, and 0 0 it is 0. Okay, so this is the first step. Okay, so now I have only 3 bits, but divisor is having 4 bits, so just take one more bit down, that is 0. Okay. Now how to start division? Check the leftmost bit. Okay. You can just observe. So leftmost bit, if it is 0, you need to use the zeros divisor. That means you have to write the 0 in the quotient, multiply with the divisor. Okay. So that is the logic. If it is leftmost bit is 1, that is the logic you need to use. If leftmost bit is 1, then you have to write quotient 1 and take the divisor. So here leftmost bit is 0. So write the 0 in the quotient and write the zeros of divisor. Okay, 0 into divisor. What you will get, all bits of divisor is 0. Okay, once again add the XOR operation, it is 0, 0, 1. Okay. Then now once again it is 3 bits. Take one more 0, it is there. You need to take that. So once again check what is the leftmost bit here. It is 1. Then write 1 in the quotient. Okay. 1 into divisor. 1 into divisor. What you will get? You will get divisor adds itself. That is 1, 0, 1, 1. Okay. Once again add XOR operation. 1, 1, 0. Okay. So only 3 bits are there. You take 0 here. So check what is the last bit, leftmost bit, 0. That means you need to take 0 in the quotient, 0 into divisor. So all bits of divisor becomes 0. Okay, just once again apply XOR 0, 1, 1. Okay, so is it I can go further still? No, because I have only 3 bits, no further bits are there. So then this is the place where you need to stop. If you have any more bits here, you just take that and continue the division. So here I don't have any more bits to be performing the division. So you can stop the division process here. So these are all, this is called remainder part. Okay. This is remainder. So now this remainder should be added along with the data. Whatever you have augmented here as zeros, now replace these zeros with this value and form the code word. So code word is equal to, write the data. What is the data? 1001. Same thing I have taken as a divisor, you can just observe, plus these 3. So instead of 3 zeros, you need to add these remainder value 1, 1, 0. Okay. So this is the code word. Now this code word is sent to the receiver. Okay. So now you need to, now receiver has to perform the same operation and calculate the syndrome. Is it everybody understood this part? If you understood, tell me, I'll go to the receiver side quickly. Is it anybody want? Understood? Okay, fine. If anybody wants me to repeat, you tell me now itself, because I'm not going to solve more
Ma'am, is the
problems.
divisor value is constant or?
This divisor one. Okay, it is not like constant. You have a number of divisors. This is the standard one. So I will talk about this divisor later. In the exam, they will give the divisor. No need to worry. Okay, in the exam, they will give the data plus divisor, and this augmenting and calculating remainder, that is your duty. Okay.
Okay, ma'am.
I'll talk about this divisor. This is not like what you want to consider. These are the standard values. Okay. So where both sender and receiver will use the same divisor. So now let me just move on to this receiver side. Okay. Here we'll consider 2 cases. Receiver side. 2 cases. One is there is no corruption. Okay. So if there is no corruption, consider what is the code word received here. I'll just write it. So code word received is 1001. Okay, plus remainder 110. This is the code word received. Okay, so unless it does all this process and syndrome is equal to 0, then only the receiver will come to know that it is valid code word. So let's do that part. Okay, so this is an example where I have considered no corruption. Okay, uncorrupted value. So this is uncorrupted value. That means no bit got corrupted during transmission. So let's take 1 0, the same divisor, okay, and the code word whatever it is sent, okay. So this code word received at the receiver side, just write as it is. Let me just change pen your color. Okay, so 1 0 0 1 1 1 0. Okay, so now use the same procedure what I have used for division purpose. So this is code word, this is a divisor. Now calculate how to do the division. So here what is the leftmost bit? It is 1. So write 1 in the quotient, 1 into divisor. Understand, first listen carefully, later you can try. Then perform the XOR operation. It is 0, this is 1 and this is 0. So take, there are only 3 bits, take one more bit from the dividend. So here check a leftmost bit. If it is 0, write 0 in the quotient and 0 into divisor. Write all bits of divisor to 0. Okay, so apply XOR operation 1 0 1. Okay, so still you have some more bits, take those bits and make it 4 bit 1. So here check what is the leftmost bit, it is 1. So write 1 in the quotient, 1 into this divisor. Okay, you will be getting 1 0 1 1. Okay, so this is 0, this is 0, this is 0. Okay, so next we have one more bit, take down one more bit, 0. Okay, so you just proceed till there is no more further division possible. Till that you have to come repeat the steps. So your leftmost bit is 0. So you need to write 0 in the quotient. Okay, 0 into divisor. So all bits are 0. Okay, so you just apply XOR operation. Okay, this is a syndrome value, S0, S1, S2. Okay, so you can calculate S is equal to S0, S1 plus S2 mod 2, mod 2. Okay, either you should get either 0 or 1. Okay, if it is all bits are 0, obviously, so here you are going to get a 0. Okay, so what is 0 indicates? No error in the received data. Will you agree? Will you agree?
Yes, ma'am.
Okay, so everybody
Yes, ma'am.
understood? In the exam, if they ask, they will give the data plus divisor. So this augmenting and calculating reminder and forming the code word, that is your duty. Okay, and at the same time, check at the receiver side also. If they tell, you take the same code word whatever you have received and do the division. Okay, if you are getting syndrome 0, it indicates no error. Just for understanding purpose, what I'll do is I'll just change one bit here. Okay, so what is the actual code word? This is the actual code word. So let me just change one bit error. Okay, so consider the received code word is 100. So instead of 1 here, consider that is corrupted to 0. It is changed to 0 and 110. This is the code word received. If this is the case, what the how the receiver will come to know that there is error. Okay, same procedure you need to do. So take the divisor, that is 0 1 1. Write this code word, received code word. This is a received code word. Okay, where this bit is modified. Instead of 1, it is changed to 0. 1 0 0 0 1 1 0. Okay, so repeat the procedure. So what is the leftmost bit here in the dividend? You take these 4 bits for division purpose first. Okay, so your leftmost bit is 1. You need to write the quotient 1 into divisor. Whatever you are going to get, write it as a dividend, partial dividend. Okay, so now perform the XOR. It is going to be 1 1 0. Okay, take the next bit here. It is 1. What is the leftmost bit? It is 0. So add 0 at the quotient, 0 into divisor. You are going to get all bits 0. Okay, So 1, 1, 1. So take one more bit down. So what is the leftmost bit? It is 1. Write 1 in the quotient. 1 into divisor. It is 1, 0, 1, 1. Okay. So XOR 0, 0, 1. Take this 0. So it is normal division, but applying for binary number. So now repeat the procedure. What is your 1? 1 indicates you need to write 1 in the quotient, 1 into divisor. 1, 0, 1, 1. Okay. So 1, 1, 0. Okay. So I don't have any further more bits for continuing the division. I'll just stop. And this is a reminder. I got it is nothing but S0, S1 and S2. So now I need to calculate. Okay, S2 plus S1 plus S0 mod 2. Okay, so what I'll get? 0 plus 1 plus 1. Okay. Okay, so what I'll get? What I'm getting? Actually, even if you don't add also, actually it is not required. Directly you can tell. This mod operation is also not required actually. So you can just tell what is the remainder you got here. See, when you want to tell there is no correction, the remainder should be 0. Okay, so other than any one bit is non-zero, so it indicates that there is a error in the received data. Will you agree? No need to calculate all that mod operation. Okay, so here you can just see if there is no corruption, if no data bit are modified, you got the S value, I mean the remainder value 0. Okay, don't do this. This is actually not required, this part. So directly you can just check the remainder. If it is 0, you can just tell no error. If it is other than 0, it indicates that there is an error in the received data. Any queries? You can ask me.
No, ma'am.
Everybody understood? This is very, very
Yes,
important.
ma'am.
If anybody not understood, tell me, I will repeat. Because I'm not going to solve some more problems. I'll give it in the assignment. And also exam, don't expect the same value. Okay, what you have done mistake few student in the first test, don't expect same value. They will give different value, but you follow the procedure. Very simple procedure. And your labeling are very, very important. Okay, write it very neatly because this approximately almost it carries 8 marks. Okay, I think it not required more than 2 minutes to perform this operation. Okay, you see the question, is it to be checked even at the receiver side? So this code word you need to consider and do the division like this. Okay, so this is an example where if they ask for corruption, if any considering any data is corrupted, then you change any one bit and calculate. Otherwise, only what is received you calculate. Syndrome should be 0. Okay, if it is 0, so the data is extracted and delivered to the receiver. If other than 0, it indicates that data is corrupted and don't deliver to the receiver, it will discard it. I want everyone. I know I am taking your valuable time, okay, but many of them are not there in the session. Let them use the recorded session to understand it. So over there, everybody understood now?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Okay, thank you. So this
Ma'am.
hardware part,
Yes,
I
ma'am.
will explain later. Okay, fine. I will explain this part later. Okay. So how this is implemented, whatever I explained, the same thing, how it is implemented. If you want, you can go through, or you give me time. Maybe after some time, I will explain this procedure because of the more number of topics I need to cover. I'll just stop that. So you people got tired. It's already 11:30. So next, the same thing. So instead, I'll just take 2 more minutes and I'll wind up the class. So instead of using zeros and ones, the same value you represent using polynomials. Okay, so if polynomial, how division takes place using CRC. Okay, to understand this, I want everybody should go through how addition of two polynomial, multiplication, division of the polynomial is done. Okay, that basic thing is required. If I want to explain that, at least it will take 15 minutes. I don't know what is the state of your interest now. Okay, this is all using binary number. If you want to, there is an advantage because you can just observe if more number of zeros are added here. So these are extra step. Okay, it is not required actually. When the divisor is considered as zero, it is wasting time by increasing the length and the time of execution. Okay, so this can be solved, this problem can be solved using polynomials. Whenever if the bit is 0, it is not required to do that step itself. You can skip using polynomial. Okay, it looks like a complex, but it is very easy. So this is the same problem is solved using polynomial. I don't know how many of you are aware of the polynomials. Okay, so the same problem is solved using polynomial. Okay, it is not complex. To understand this procedure, it requires like you should know what how to do shifting. Okay, dividing polynomials by one another, multiplying. Okay, adding, subtracting polynomials, how to find the degree of the polynomial. If you go through this, I think I can explain this in the next class. Shall I continue or shall I stop? Whatever you tell. Okay, so I don't want to take much of time. Let me just stop. So tomorrow's class, I don't know tomorrow I'm going to get the class or not because there are some event is going to be happen in second hour. If they tell me to take you people there, so then I may not get tomorrow's class. That is the reason I took. Okay, so in the next class we'll do all this. And there is one more topic I need to cover, that is called checksum, internet checksum.